All right, let's just jump right in. We all know the periodic table, right? That huge chart from high school chemistry, pretty much a settled fact of science. But what if it's not just a chart? What if it's a code? A code that's hiding the actual blueprint for all of matter. You know, for hundreds of years, we've looked at it as this incredible human achievement, a catalog of reality that we painstakingly put together, piece by piece. It's like the ultimate list of ingredients for the entire universe, from hydrogen all the way to Oganesson. But here's the twist. What if we didn't just discover all this stuff? What if the existence of every single element, their properties, the exact number of them, what if it was all predetermined, all laid out from the very beginning by a single elegant law, a literal architectural plan for reality itself? Now, to even think about that, we've got to look way beyond the familiar chart we all know. See, for more than 100 years, the standard view was that the table is empirical, which is just a fancy way of saying it's a list of stuff we found. We observed it, we measured it, we wrote it down. But the idea we're digging into today is totally different. It's the idea that there's a hidden mathematical rule that doesn't just describe the table, it actually builds it from scratch. So, what is this universal equation, this master key to the elements? Let's take a look.
Well, this part of the story really gets going back in 1997. That's when a researcher named Jean-Claude Perez came out with something that, frankly, most people missed. A single, compact formula that he said could predict the entire structure of the periodic table.
And there it is, the Generic Equation of Mendeleev. Now, I know it looks kind of complicated, right? But its real power, its genius, comes from just a few super simple parts. You've got the period number, the number 2, and an operator that just makes sure the answers come out as whole numbers. That's pretty much it. That's the engine. And this quote from Tesla, it just fits so perfectly. Perez's work was exactly that. It was like planting a seed, an idea, over 20 years ago that's really starting to show us a completely new way of looking at the world. So how in the world does such a simple equation build something as complex and beautiful as the periodic table? Well, the secret, it's like a dance between two opposing forces. The real magic of the equation is right here. It's this incredible balancing act. On one side, you have this powerful force of perfect symmetry. But on the other, you have just a little touch of asymmetry, which you absolutely need to create anything interesting. It's the tension between those two that builds, well, everything. And the engine driving all that order is the number 2. I mean, look at the formula again. It's everywhere. You multiply by 2, you divide by 2, you add 2, you square it. That constant drumbeat of 2 is what forces matter to organize itself into these stable, predictable, symmetrical pairs. It's the rule that keeps the universe from just becoming a chaotic mess. Okay, so it's a beautiful theory, but a theory is just a theory, right? A key that can't open a lock is just a weirdly shaped piece of metal. So the billion-dollar question is, does this thing actually work? So the first big test, the most important one really, is to see if we can use it to predict the world we already know. We can just take the period numbers from our existing table, plug them into the formula, and see if the answers match up with reality. And here we go. This is the moment of truth. For period 1, you plug in the numbers, and the formula predicts 2 elements. We have 2, check. For periods 2 and 3, it predicts 8 elements. That's exactly right, check. Periods 4 and 5, it says there should be 18. Bingo, correct again. And for 6 and 7, it predicts 32. It is a perfect 100% match every single time. So let that sink in for a second. This mathematical law works perfectly, without a single exception, for every known element in the universe. This isn't just kinda close. It seems to be a fundamental rule of nature itself. All right, so now that we know the key works on all the doors we've already opened, it's time to get adventurous. Let's use it to peek behind some doors that no one has ever opened before. Let's head out to the theoretical horizon. You see, our current table pretty much stops right here, at the so-called radioactive boundary with super heavy, unstable elements like oganesson. But the math doesn't care about that boundary. The equation just keeps on going, predicting whole new layers of matter far beyond anything we can cook up in a lab right now. And this is where things get absolutely wild. The scale here is just staggering. The formula predicts that periods 8 and 9 should have 50 elements each. 50? Then it gets even crazier. Periods 10 and 11 jump to 72 elements. And if you go way, way out there to period 16, it predicts a mind-bending 162 elements. And what's really cool is that it doesn't just predict how many. The theory lets us start to imagine what these things might be like. The research even gives a hypothetical name to one of them, Aether, with atomic number 126. And get this, the model predicts that even with that massive nucleus, it would be as light as hydrogen. How is that even possible? It's a complete paradox. So obviously, with this many new elements on the horizon, our little flat 2D chart just isn't going to cut it anymore. It's obsolete. The logic of the equation itself demands that we start thinking about the elements in 3 dimensions. And one of the most beautiful ways to visualize this is the K-crystal model. What I love about this is that it doesn't throw out the old table. It keeps all the familiar groupings, the alkali metals, the noble gases, but it weaves them into this gorgeous, expanding 3D shape. It's an evolution, not a revolution. And this is where it all comes together. The periodic table isn't some random list of things we found. It's a quantum crystal. It's something that is alive, always growing in these perfect, predictable patterns. And the whole thing is governed by that one simple, elegant code we saw at the beginning. So it really leaves you with this one huge final question. If the entire blueprint for all the matter we can see and touch is built on a code this simple, what other secrets does the universe have? What other cosmic truths are just sitting there, waiting for us to find the key?